Okay, so go ahead and get back to title in your notes if you didn't already do that. And now we kind of need to talk about each one of those, and we're going to do some math with them. So these are all terms and help us understand what happens in a chemical reaction. Drake, you okay?
Yeah.
So these are things that we will use on and off for the rest of the year. So I'm going to tell you right now, today is like a little tiny easy piece of it and it all builds. If you get to the point where you are like lost and you don't know what you're doing, stop right away and figure it out. Come see me, ask for help, whatever. But don't let yourself get behind in this stuff because it all builds for the rest of the year. We'll use it one chapter, not the rest, and then the next chapter we'll add something to it. We could also say that this is the basis for relating what happened. In a chemical reaction. So that's two different ways we can look at it. And I'm going to start this with a guy with the last name Avogadro. His name was actually Emilio Avogadro, and he spent a big part of his life studying, I'm going to really abbreviate this for you, carbon 12. So, when you see that, what does that number mean? Or what is that number?
Atomic mass.
Mass number. How would you know? Or here's a better question. What is this? What? We need to add a little bit more to it, Drake. Average atomic mass. Good. So be sure you know the difference between the two. Okay. So he studied carbon 12, and he found that 12 grams of carbon 12 contained 6.02 times 10 to the 23rd atoms, or you can say particles, of carbon 12. So that's the first thing you figured out, just by a bunch of experimentation, that number that you find on the periodic table has that many particles in it. This number right here, Avogadro's number, I'm going to keep talking about it, but that's something we're going to use all year. That's something you need to memorize. 23rd. So this is called Avogadro's number. And it is a constant. It's kind of like in math, how pi is a constant. Doesn't change. Avogadro's number doesn't change. So then he did some more experiments. And he found each mass of each element on the periodic table contains 6.02 times 10 to the 23rd atoms or particles. Now, get your periodic table out from you. Or pull your periodic table to the top. So if we look at our periodic table, I need to grab one. And let's find, well, I'll find calcium to start with. Look at the average atomic mass of calcium. Oh, let's try to make it cut out. I don't want you to miss this. When you find the average atomic mass of calcium, what is it, Wes?
40.87.
Okay. And if we rounded it to the tens place, we'd call it 40. What? Hello, right? How many particles does that represent on the periodic table, based on what we just said?
6.02 times
6.02 times 10 to the 23rd. Good. I could do the same thing. I could hop down to element 31, gallium, and I could look at its mass. And in that mass, there are 6.02 times 10 to the 23rd particles. I could hop down to tin, element 50. Look at its mass. Still, 6.02 times 10 to the 23rd particles. How would you compare the particles of gallium to the particles of tin? Which ones are more massive? Which ones are heavier? Right? Tin. Why'd you say that?
It weighs more, but it's the same amount.
It weighs more, but it's the same amount. So now, I want you to think about that. Every single thing, each little box on this periodic table, if I say, how many atoms does it contain, every single one of them represents 6.02 times 10 to the 23rd atoms. It's like an easy answer. They might weigh different, like the atoms all weigh different, but there's the same amount of them. Okay? So far, so good? Then I want you to think about each box on the periodic table as representing 1 mole of that element. Now, that is not a mole like the one that digs up your yard, and it's not a mole like the Wicked Witch has on her face with the hair coming out of it. It's a chemistry term, a mole. It has a special meaning in chemistry. And a mole is actually the weight in grams of 6.02 times 10 to the 23rd atoms of a substance. It doesn't matter what the substance is. It has a weight, and that weight contains 6.02 times 10 to the 23rd particles, if it's a mole. So, every single little box technically on this periodic table represents 1 mole of that element, whatever it is. Now, I'm going to ask you a question. Let's use aluminum. See if you can do this. These are the things I want to know about it. Number of protons, put this right in your notes. Number of electrons, number of neutrons, number of particles in 27 grams. And I want you to see if you can remember how to write it in height and notation. We're going to do this stuff all year. and nuclear symbol. Do that. Yeah. What? It is. He started working with carbon 12. And he figured out how many were there. And then he moved to different places on the periodic table. And what he found was the weights all contain the same number of particles. Because that's the weight of one atom of particles, or one mole of particles, I should say, not one atom. See if you can do those things. So we have some disagreement on this first table. Let's see how you guys do. All right, Maria, tell me how many protons does aluminum have? She says 13. What did you say, Mary? 13, you agree with her? How about electrons, Evan? What did you say? Thank you. Anybody say 14? Honestly? Oh, okay. We'll get there. Why'd you say 14?
I can do that.
Okay.
But I don't know if it's
Now, how about number of neutrons? Do we have a number of neutrons, Kevin?
14.
14. So what I found first period, and it might be the same thing with you guys, is they were trying to use mass number minus atomic number to get electrons instead of neutrons. So remember, if you didn't get those, this is mass number minus atomic number. This is just atomic number. This is just atomic number. So those are straight off the periodic table. Why can I take them straight off the periodic table, Lucas? And what else? Anybody else help him? Devin, can you help him? Why can I take them straight off the periodic table? Why? What about the atom lets me do that? Lucas, you got more info?
not sure. I'm just stating
Well, is that what this means? Maybe not really?
I feel like I'm stating what we already know, but I don't know if it's clear.
Well, maybe that's what I'm asking. What do you want to state?
The number of protons is good.
Xander, can you help him? Oh, come on! Y'all asleep today? Did you eat too much candy yesterday? Great.
The number of protons is the atomic number, and the number of protons and electrons are always equal because the atoms are neutrally charged.
Good. Atoms are neutrally charged. Look at that. That will show up again. All right. Number of particles in 27 grams. It's not like they knew that. Akaya, did you know that? Shelby, did you know that? Devin?
What?
Oh my gosh, Devin, where are you?
The answer?
Yeah, what's the answer, Devin?
Is it just 6.02?
Yes! Always! Look at this mass. It's what's on the periodic table. So it's 6.02 times 10 to the 23rd. So let me get you on that. Because I guarantee you thought you had to multiply? Yeah. It's always the same. Now, there are times when you're going to have to multiply, but we're not there yet. Right now, look at your periodic table. That's what it says. And there's 6.02 times 10 to the 23rd. Hyphen notation. I put these two up here because a couple of you had a little trouble on the quiz with them. Wes, how'd you do hyphen notation for aluminum? Yeah, that's 27. I'll take that. Oh, over there in the corner. Let me have you do this one. Up here? Okay. Okay. So, I would say this nuclear symbol honestly was one of the most missed things on the quiz. Some people put these on the other side. Some people flip-flop them. This is always mass number, this is always atomic number. And then some people just made things up. So, if you're one of those people, mass number, atomic number, you're gonna get more practice at it, but don't forget the things you did on the first quiz, because they're gonna show up a lot. All right, so the mole. Weight in grams of 6.02 times 10 to the 23rd atoms of a particle. And then we have one more term that goes with this. Molar mass. And it is simply, it's easy, mass in grams of 1 mole of any substance. So it's also, I could say it this way, the mass in grams of 6.02 times 10 to the 23rd atoms of any substance, because we know 1 mole is 6.02 times 10 to the 23rd atoms. So Avogadro's number kind of links them together. So now we're going to work with this molar mass for a little bit. That calculated that?
Yep.
Okay. So we're going to start off easy, and then we'll work up to the more difficult ones. And I'm going to show you some different wordings so that when you get them, hopefully they won't confuse you. So I'll start by saying how many grams, no, how many grams equal 1 mole of, let's pick nickel. How many grams equal 1 mole of nickel? So this will be A, and then B will be so, see if you can answer those two. How many grams are in 1 mole of nickel? How many atoms are present in 1 mole of nickel? Let me tell you this too. For molar mass, like we're working with right now, you're going to round to the 10th place. Always. That's just the rule we're going to follow. Xander, how many grams are in 1 mole of nickel? 58.7 grams per mole. That's how I would write that. Look at that. The abbreviation for mole is drop the E. Not much of an abbreviation. Maria, how many atoms are present in 1 mole of nickel? 15 to 200. Yes. So, that's about as easy as they can be. Let's look at one that's harder. Let's see, what is the molar mass of nitrogen monoxide? What is the molar mass of nitrogen monoxide, NO? See what you come up with. See if you followed those steps. Go to your periodic table, find the mass, I should say round to the 10th place, add them together. So when I found nitrogen versus oxygen, isn't nitrogen like 14.001 or something close to that? 7. Okay, so I would just call this 14.0 grams per mole. And if I go find oxygen, it's like 15.999. So I would round it to 16 grams per mole. Then I would add those together and I would get 30 grams per mole NO. And that's how I would write it. Ooh, let's try one that's harder. You ready? Are you awake? All right. What is, oh, that means what is the molar mass of glucose? Uh-oh. Anybody know the chemical formula for glucose? From good old Mrs. Bayer in biology? Oh.
C6N12O6.
Oh, so close. C6, what's my second element? Not N, but H. Good. C6H12O6. Now, don't do anything else until we talk for a second. You know what these things down here are called in the chemical formula? Anybody? What? Good. It tells us how many there are. They're just called subscripts. And it equals how many of each element there are in the total compound. So when I look at this one, I know I have 6 carbon, 12 hydrogen, 6 oxygen. So I'm going to use that info. I'm going to write it out like this. C equals, H equals, O equals. And I'm going to have to do some multiplication here. I have 6 carbon, I have 12 hydrogen, and I have 6 oxygen. Once I have that lined up, I'm going to go to my periodic table and I'm going to find their molar masses. If you check carbon, it's 12.0. If you check hydrogen, it's 1.0. That should be right in there per mole. And if you check oxygen, we just talked about how it's 16.0 grams per mole. Then you have to do your math. Do that. See what you come up with. Get an answer and then just, oh, when you have an answer, stand up. All right. Find your lab partner and see if you guys agree. Move around a little bit.
I love some salmon. It's good.
All right, is that what you got?
Yeah.
Yes? Here's my question. How many atoms are in 180 grams of glucose?
No, it's 6.02 times 10 to the
6.02 times 10 to the what, Connor?
23rd.
23rd. Hey, that's what that number is up there. Above my.
Oh my goodness.
That's Avogadro's number when you write it out. All right, I'm going to give you one more, and then I'm going to let you get some homework done. Well, it might not be homework. We'll see. Try this one. No, but let's think of it. Let's try this one. What is the molar mass of aluminum phosphate? Oh, anybody know the chemical formula for that?
AO
Well, that's a good starting place.
3.
I don't expect you to know yet. Eventually you'll be able to tell it to me. It looks like this. Al3 PO4 twice. And that's exactly how you write it. And we'll talk about it in just a second. I wouldn't expect you to know that yet. So, this is how we handle this when something's in parentheses. AL, how many of those do I have? 3. When I have something in parentheses, this little subscript outside, you don't add it, you multiply. This is telling me to multiply each element's subscript. So when I write these down, I should have P and O, and I should have P is 2 times 1, so I have 2 of those, and oxygen would be 2 times 4, so I have 8 of those. Now you figure out the molar mass. You guys, it's phosphorus 31. Okay. When you have an answer, stand up. Okay, when you're ready, check with your partner. Does your answer look like this? Do you have it written out just like that?
No.
Did you include the chemical formula?
Yes.
If you did, good. If you didn't, not good. Put your chemical formulas on there. I need the whole thing to give you full credit. Now here's my next question. What do you think it's going to be? Drake?
How many atoms are in 271 grams of aluminum phosphate?
There you go. What's the answer? Everyone!
6.02 times 10 to the 23rd.
Okay, again, until everyone participates. What's the answer?
6.02 times 10 to the 23rd.
Okay, thank you. Now, pull that packet out that says isotope practice. Go to the, I think it's the very last page. We haven't done anything with it. You now can work on that with your lab partner. Maybe you'll get finished. Maybe not. If you don't get finished, you need to finish it. Okay? All right, let's go.